Yeah. So the next topic is stoichiometric. Stoichiometry and stoichiometric calculations. Okay, stoichiometry and stoichiometric calculations. When come to stoichiometry and stoichiometric calculations means we need to write the balancing equation with the proper uh, the stoichiometric numbers. Okay, see for example, if you take one example equation, say example CH4 when reacts with the oxygen, so that gives out carbon dioxide plus 2H2O. So in this case, these are the numbers very important to balance the equation. Here, two molecules of oxygen, so that gives out when reacts with methane, that gives out carbon dioxide and two molecules of water. See, this equation we can explain in the form of four types. So first one is, see, 1 mole of CH4, so that is reacts with so 2 moles of, next one is 2 moles of oxygen to give the 1 mole of, here this is 1 mole you have to take, so 1 mole of carbon dioxide and 2 moles of water. This is one type based on number of moles. Second type is, so that is based on molecule. See, one molecule of methane reacts with two molecules of oxygen, gives 1 molecule of carbon dioxide and 1 molecule of water. Third one is based on molecular mass. Say 16 gram of CH4 reacts with that is 2 into, so 32 gram of oxygen to form that is 44 gram of 44 gram of CO2, and so 2 into 18 gram of water. The same equation we are explaining in the form of different forms. Okay, this is based on molar mass, this is based on number of molecules, this is based on number of moles. Last one is based on volume. That is, so 22.7 liters of methane reacts with so that is a 2 into 22.7 liters of oxygen gives that is 22.7 liters of carbon dioxide and 2 into 22.7 liters of water. Okay, so the one equation we can explain in the form of different forms. So what type of questions we can expect from this one? Okay, so example, we'll see a few examples. See example, calculate the amount of water amount of water produced by the combustion of 16 gram of methane. 16 gram of methane. Okay, so first you start with the balancing equation CH4 plus O2, that gives out CO2 plus H2O. So in this case, here two molecules you take, and here two molecules of water. So what is the question? Calculate the amount of water produced by the combustion of 16 gram of methane. So they given in grams. Okay, here also how much amount of water is produced. We know that uh, the first statement, when 16 gram of methane, so that gives out, so how much grams of water? So that is 2 into, that is 18 grams. Okay, 2 into 18 grams of water will get. 18 gram of, so water will get. Okay, so that means 36 grams. So 36 gram of, so water. So this is the answer. See, 16 gram of methane gives out uh, that is 36 grams of water means. So we can write directly this one. See, for example, instead of 18 grams, instead of 16 gram, in case they given 8 grams. So here, 8 grams. How to do this one? 8 grams. See, 16 grams of methane. Okay, 16 grams of methane gives 36 grams of water means. Okay, so when you take methane, 8 grams of methane, 8 grams of methane, so that gives out how much grams of water, that one take it as a x. So that is x equal to, that is 36 into 8. Okay, so that is divided by 60. Okay, so that gives out how much? Okay, so that is gives out. So in 36, you have to make it like half. Okay, so that is 15 and so we'll get 18 grams. Okay, so 18 grams of, so water we'll get. So this is numerical. See, I'll take one more numerical. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion. After combustion. So in this case, you check how many moles of methane are required to produce, so 22 gram of carbon dioxide. First, you know the equation CH4 plus O2 gives out CO2 plus H2O. Right, CO2 plus H2O. See, here 2 moles you have to take, here 2 moles. This is the balancing equation. So in this case, you check here 22 grams of carbon dioxide is produced. Based on this balancing equation, we know that 16 gram of, okay, 16 gram of CH4, that gives out 44 gram of 44 gram of uh, CO2. Next, but we need here relation, you check here moles they given, they're asking moles. That means 16 grams means how much? 16 grams means it is 1 mole. See, 1 mole of CH4, 1 mole of CH4 gives out how much? 44 gram of carbon dioxide. Now, they didn't ask 44 grams, they didn't give 44 grams. Here they given 22 grams of carbon dioxide instead of 44 grams. Now, how much moles of methane is required? So unitary method you have to do. Okay, so in unitary method, for 1 moles, how many? 1 moles will get 22 grams, means that is 22 into 1 equal to 44 into x. So x equal to 22 divided by 44, that gives out 1 by 2. So that gives out 0.5 mole. Okay, so 0.5 moles of methane is required. Okay, so this is related to stoichiometric calculation. Next topic, when come to next topic, so that is limiting reagent. So limiting reagent. So limiting reagent means, see, the reactant which is present in the least amount, okay, gets consumed after some time, and after that further reaction does not takes place. Okay, so that the reactant quantities decreases, and the product formed, and the amount of reactant, okay, amount of reactant is very less. So that time one of the reactant is less quantity, so the product also will get the limited product will get. Okay, so that reactant we have to identify, because one of the reactant will consumed fast, okay, limits the amount of product form, and therefore it is called as limiting reagent. Okay, so that is limiting reagent. So how to identify limiting reagent means, for example, I'll take general reaction A plus 2B, so that gives out C, example. Okay, so this is the general reaction. This is the general reaction. In this case, 1 mole of, see, 1 mole of A when reacts with the 2 moles of B, that gives out 1 mole of C. That is a product. Okay, this is the proper 100% balancing equation. See now here. So when you take 0.5 mole, 0.5 mole of A, okay, plus here we are taking like 1 point or 2 moles. Okay, 2 moles of B. Okay, so 2 moles of B. So this, in this ratio, which one is limiting reagent? The proper ratio is what? 1 is to 2. A should be 1 and the B is should be 2. Then only you'll get 100% product. But here, instead of 1 mole, here 0.5 mole is there, and the B is a 2 mole remains same. That means what? The limiting reagent is reactant A. Okay, so the A is the limiting reagent in this. A is limiting reagent. Similarly, so when you take 2 mole, okay, so 2 mole of A, so reacts with the 2 mole of 2 moles of 2 moles of B. So which is the limiting reagent in this? The limiting reagent is C. You know that ratio is 1 is to 2. Here 2 present means here it will be 4. But here only is present. So this is the limiting reagent. So like one of the reactant is less quantity and it gets consumed fast. Okay, and limits the amount of product. So that we call as limiting reagent. Okay. See, example, we'll do one numericals. So we'll get idea. See, when come to so 50 kg, 50 kg of N2 and 10 kg of H2. are mixed to produce NH3. Calculate the amount of NH3 formed. Identify the limiting reagent in the production of NH3 in this situation. See, the balancing equation, this is the solution. So the balancing equation for this reaction, so that is preparation of ammonia. So N2 gas, so reacts with 3H2 gas, reversible reaction that gives out 2NH3 gas. So that gives out balancing equation. First find out in 10 kg, 50 kg of nitrogen, how many moles of nitrogen is present? In 10 kg of hydrogen, how many moles of hydrogen present you have to convert? That means you have to convert that 50 kg into moles. Okay, 50 kg means you converted into grams. Okay, 50 kg means that is 50 into 1000 you have to do, because you have to convert it into grams. Okay, so after that, what is the mass of nitrogen? So the mass of nitrogen is, so this is given mass. Okay, given mass divided by molar mass. So given mass is 50 kg, you have to convert into grams. And the molar mass of nitrogen is 14 plus 14. So that is 28. Okay, so that gives out, that is 17.86 into 10 to the power of 2 mole. So this many moles of nitrogen present in 50 kg of N2. When come to number of, this is number of moles of N2. Next, moles of H2. Moles of H2 is 10 kg, converted into grams, that is into 1000, divided by the 2 hydrogen is present. So that exact mass of hydrogen is, that is 2.0116. This is for 2 hydrogen H2. That gives out, that is 4.96 into 10 to the power of 3 mole. This many moles of hydrogen present in 10 kg. This many moles of hydrogen present in 50 kg. After that, according to this equation, you have to check, okay, for what is the ratio is there, you have to check for, okay, 1 mole of nitrogen required. See, 1 mole of nitrogen is required. So 3 moles of hydrogen is required. Okay, that means 1:3 ratio. 1:3 ratio is there. Okay, according to that ratio, you have to check how many moles of hydrogen is required. Okay, that means 17.86 into 10 to the power of 2 moles of nitrogen present. Okay, that is how much? 17.86 into 10 to the power of 2 moles of nitrogen present. For this one, how many moles of this one hydrogen is required? That one you have to calculate. But we know already for 1 mole, see, 1 mole of N2 required 3 moles of hydrogen is required. Same concept here for 17 moles of nitrogen. How many moles of hydrogen is required? Unitary method you have to do. So after doing unitary method, that is x is equal to, so how much we'll get? That is 3, right? So 3 into 17.86 into 10 to the power of 2. Okay, so that gives out, that is 5.36 into 10 to the power of 3 moles of hydrogen is required. Okay, but now for this many moles of hydrogen is required, but we have how many moles of hydrogen is there? We have only, that is 4.96 into to the power of 3 moles of hydrogen is present, right? But here 5.36 into 10 to the power of 3 moles of hydrogen is present. Okay, then what is the limiting reagent? The limiting reagent is which one? Okay, so that is dihydrogen is the limiting reagent. Okay, therefore, uh, dihydrogen. Dihydrogen is the limiting reagent. Okay, after that we have to calculate, see, identify the limiting reagent. After that, in the production of NH3 in this situation, we have to identify the or calculate the amount of ammonia formed. We have to calculate this one also. Okay, calculate amount of NH3. See now, according to that balancing equation, see, for 3 moles of H2, that gives out 2 moles of NH3, the balancing equation, according to balancing equation. But how many moles of hydrogen present? So that is 9 point, that is a 4.96 into 10 to the power of 3 moles of hydrogen, that is mole of hydrogen, gives out how many moles of ammonia. So again, unitary method, 3x equal to 2 into 4.96 into 10 to the power of 3 moles of hydrogen. Hydrogen is required. So x equal to 2 into 4.96 into 10 to the power of 3 divided by 3. So that gives out how much? It gives out 3.30 into 10 to the power of 3. That is mole of NH3. This is moles. Okay. So now we have to calculate amount of ammonia. Okay. We know that 1 mole of NH3, that is equal to 17 gram of NH3 present. So 1 mole of ammonia mass is how much? It is 17 gram. But how many moles of ammonia present we have? So that we have 3.30 into 10 to the power of 3 moles of ammonia is present. Mole of NH3 present, that gives out how many grams. Again, unitary method you have to use. This is x gram. So now x is equal to, that is 17 into 3.30 into 10 to the power of 3. That is 3.30. So that is 17 into 3.30 into 10 to the power of 3. That gives out how much? So that gives out 56.1 into 10 to the power of gram of NH3. If you want to convert it into kg, that is 56.1 kg of ammonia formed. Okay, so this is related to limiting reagent. Limiting reagent, yes. Then go to next topic, that is reactions in solutions. Next topic, reactions in solutions. solution. So concentration of solution or amount of substance in its given volume expressed any one of the following ways. One is that is a mass percentage. Second, by 1. First one, when you take mass percentage, so what is a mass percentage formula? So mass of solute divided by mass of solution. Mass of solution means solute plus solvent. Solute plus solvent. So that is solution. See example, a solution is prepared by adding 2 gram of a substance, 2 gram of a substance, that is A, to 18 gram of water. Calculate the mass percent of the solute. So mass percent is equal to mass of A divided by mass of solute into 100. A is the solute. So that is 2 gram given. Mass of solution is how much? That is 2 plus 18. That is water, right? So that into 100. So that gives out 10%. That gives out 10%. That is mass percentage. So next topic, that is mole fraction. Second one is mole fraction. Mole fraction is denoted by X. So formula for mole fraction, number of moles of solute divided by, so that is total number of moles of solution. Here, it is that mole fraction. Okay. So third one is molarity. It is denoted by M. See, the molarity is defined as there is capital M. So that is number of moles of solute divided by, so volume of solution in liters. Volume of solution in liters. That is fourth one. That is molality. Small m. Here the number of moles of solute divided by mass of solvent in kg. mass of solvent in kg. So these are the formulas. So we'll do some numericals now. Calculate the molarity of NaOH in the solution by dissolving its 4 gram in enough water to form 250 ml of the solution. So now molarity we have to find out. So molarity we need the number of moles. Okay, the number of moles of solution divided by volume of solution in liters. So number of moles how to find out. Number of moles means given mass divided by molar mass. So molar mass of sodium hydroxide is how much? It is 40. Divided by convert molarity. Molarity is equal to what? Given mass is 4 and molar mass of NaOH it is 40 divided by that volume. How much volume given? It is 250 ml given. You just converted into liters. That is divided by 1000. You have to do that. Gives out 0.25 liters. Okay, so that gives out. So that is 0.250 liters. So that gives out 0.4 mole. Okay, or 0.4 molar. This one. So when come to next numerical, so the density of 3 molar solution of NaCl is 1.5 gram per liter. Calculate the molality of solution of the solution. So M is equal to 3 mole per liter and mass of NaCl you have to find out. Mass of NaCl is equal to, okay, in 1 liter. In 1 liter. In 1 liter solution, so that is 3 into 55, that gives out 175.5 gram. Next, mass of 1 liter solution. To find out mass of 1 liter solution, that is equal to how much? So 1000 into 1.25 because density is right. So that gives out 125 gram. That is 1250 grams. Okay. After that, mass of water in solution you have to find out. Mass of water in solution equal to, so that is 1250 minus 75.5. That gives out 1074.5 grams. This much you'll get. After that, you have to use the formula. Yeah, the formula is molality is equal to number of moles of solute divided by mass of solvent in kg. Okay, so that one is 3 moles divided by 1.074 kg. That gives out 2.79. Yep. Okay, so 2.79 molality. So this is the answer. Okay, so this type of they can ask different questions. So this is some basic concepts of chemistry chapter, all topics we covered. Okay, so next class will in next video we'll do chemical bonding and molecular structures. Thank you.